Hi, welcome to this video learning. We are looking at 4AC example 1.4a, which can be found in your notes. This example reads, a sinusoidal voltage waveform is given as follows. Vt is 325 sine 377t volt. What we want to do is to determine the angle and the time when the voltage reach 100 volt. And we also want to determine the voltage when the time has passed to 2 milliseconds. And finally, to sketch the waveform with the abscissa, number 1 in angle in degrees, angle in radians, and finally time in seconds. Let's see how we are going to do that. Well, to answer these questions, what I want to do is I've just written out the typical standard expression of the sinusoidal waveform, and I can compare these two to derive a few things, right? Number one is that the angular velocity is 377 and the V peak or V maximum is 325 volts. Right? Now from this I can derive the period t, because omega is 2 pi f. From here frequency is 377 divided by 2 pi. That gives me 60 hertz. Which means that t is 1 upon f. T will be 16 points. Okay. T is 1 upon f. So that gives me t is equals to 1 over 60, which is 16.667 milliseconds. Now, in A, we want to know when the voltage reached 10. Now, notice that when the voltage reached 10, there are 2 points in this sine wave that I can derive on. So let me focus on the first one. Now, what we do is we can substitute the values of 100 volt into the equation, and from here I can get the values. So let's do it here. 100 volt is equals to 325 sine of 377t. Therefore, sine of 377t, which is in radian, is actually 100 over 325, which is 0.3127 radian. Right? Okay. So this is the angle expressed in radians. The other way is if I want it in degree. Since it's in radian now, degree will be just 0.3127 divided by 2 pi multiplied by 360 degrees. So that gives me 17.92. So it can be expressed in angle. Now, how do we convert that to time? Time is basically, I can use 0.3127 radian, which is the point where which is here, divide by the total cycle. One cycle is equivalent to this, multiplied by t. That gives me 3127. Let's use a calculator. 0.3127 divided by 2 divided by pi multiplied by the period t, which is 16 0.667. Right, I just round it up. Is equals to 0.832. Sorry, 0.829. So that's about 0.83 milliseconds. Now at the same time, there's another point here. So at this point, when it's 100 volt, we have calculated this to be 0.83 milliseconds. So what about this point? To find that point, we make use of the fact that sine of this value can be due to two angles, right? That's why I said sine of the first angle, in this case 17.92, is the same value as sine of 180 minus this value. Okay, let's do a quick check. In this case, sine 17.92 degrees is equals to sine 17.92 is 0.30768. Similarly, sine of 180 degrees minus 17.92 degrees is equals to 180 minus 17.92 is this angle. Okay. And if I sine this angle, sine of 162.08, I get the same value, 0.30768 as well. So it tells me that this angle is 17.92. This angle is 162.08. Right? So that's how this angle can be determined. So this corresponds to the first angle. This corresponds to the second angle. So second angle is this, or the radian of this, right? So radian of this, I can use 162.08 divided by 360 degrees. Divided by 360 degrees multiplied by 2 pi to get this one. Now the first time we already calculated, so now for me to calculate the second times, what I need to do is to use I will use omega T2 equals to 377 is 2.8288. T2 is 2.8288 divided by 377. And that will gives me 7.5 milliseconds. Right, that means at time t1, the corresponding angle in radian is 0.3127, whereas time t2, which on this side now, is actually the omega t2, which is in radian, which is equals to this one now. So from here, I calculate it is 7.5 milliseconds. And finally, for the part B, now part B basically wants us to calculate what is the voltage level when the time has reached 2 milliseconds. In other words, I make use of the formula Vt is equals to 325 sine of 377t. All I need to do is substitute the time in, but I must remember to convert it to seconds. So that's 325 sine of 377 times 0.002 seconds. Right? So solving for it, I will get 377 times 0.002. Now remember, this is in radian. So if I want to calculate in angle, I must convert this to degree. So so this one is 325 sine 377 times 0.002 seconds is actually 0.754, but this is in radian. Okay, so if you want to calculate sine, must remember to convert your calculator to radian or convert this whole thing to degrees. So if I want to use it in degree, I must remember to convert. So radian divide by 2 divide by pi multiply by 360 degrees. That will convert this to angle 43.20 degrees. So my answer now is, I take the sine of this value multiply by 325. That is 222.48 volts. That's my answer here. Okay, and part C, I need to find the frequency. So here is 377. We have calculated this earlier. Therefore, frequency is given as 377 divided by 2 pi. That's worked out to be about 60 hertz. So 1 over 60 hertz is just 16.667 milliseconds. So if you want to draw the three waveforms in degrees, in radian, or in time, this one we can just put in here, 16, half of it. Right? Now in radian, we convert the equivalent. Right? Here is 360 degrees. So at this point, everybody is 1 cycle. And this is the period that we're talking about. So the waveform all look this way. If I express in degree, the crossover point is 180. The peak period occurs at 90 degrees. At 270 degrees. And then finally 360. Right? Whereas here, we can equate this to pi over 2. 3/4 pi. And then 2 pi. 3/4 pi. Is it correct? Okay, finally, the time when it occurs to be maximum is 4.16, and then here is 12.49 milliseconds. I think something is wrong. Okay, pi over 2 plus pi over 2 is 3 pi over 2. This is pi plus pi over 2, so it's 3 pi over 2. Okay, so here you are. These are the three ways I can draw this waveform with different time values. Okay, so that's all for this example.